This is our new semesters beginning today, the third quarter, and schedule for the month of January is all here. We will work on chapter 4 of our textbook, Polynomials. This is going to take all the January, all the month of January. We have a break, a small holiday here on January 18, but all the other days we will work, we will practice, we will solve quizzes about polynomials. And what is polynomial? I like to ask you to keep things really simple on this course. You don't need to know definitions, very complex definitions. You can make up your own definition. We will work on properties of polynomials, addition, subtraction, multiplication, greatest common factor of polynomials, factoring, and also solving equations. Okay? This is everything that we're going to work, that we will do about polynomials. But the first and very important question is, what the heck is polynomial? What means polynomials? And I like this very simple explanation here, this very simple definition. You can create your own definition. After you understand, you can create your own definition. Polynomials is something that looks like this. It's an expression that have different terms, a bunch of terms. And you can think as one of the ways to understand polynomials is to understand the name, because it's a combination of two different names. Poly that means many, and nomial means name, means term. That means many terms, or a bunch of terms. And if you see this example here, this is a polynomial. We have one term is this one, 4x times y squared. Another term is this one, 3x, and another term is this one, negative 5. So if you put together a bunch of terms, you have a polynomial. Again, don't get don't get busy thinking or worrying about complex definitions. Try to understand and make your own definition as long as you understand the meaning. And keep it simple. We will work on properties of polynomials. Lots of properties. Can you see here? Multiplication, division of like bases, power rule, power of a product, power of a quotient. But today I want to keep things kind of slow and not too hard. So let's skip this. We will see all these properties tomorrow. And today we're going to work on just some basic, some simple properties, some simple exponents, simplifications. Okay? So we have this definition of b exponent 0 and b exponent negative n. Let's work on this today, and tomorrow we work on the other properties. First one, very easy one. What is b exponent 0? If you have a number different from 0, let's say 5, and you apply an exponent 0. The result of any number different from 0, exponent 0, is always going to be 1. So this is very simple, okay? So if you have 5 exponent 0 equals to 1. If you have 5,000 exponent 0, this is also equals to 1. If you have negative 5, 1, 3, 4, 7, 9 exponent 0, this is equals to 1. So anything, any real number different from 0, exponent 0 is going to be equals to 1. Pretty simple, right? Let's go to the next. Negative exponent. If you have a number and you submit this number to a negative exponent, this is the same thing, is equal to having the inverted number, exponent, the positive n. So let's check an example here. 4 exponent negative 3. This is equal, the same thing, as you get this number 4 and you invert and you apply the same exponent but with a positive sign. So this is equal, okay? Right now, just remember this. Just remember this first step. On the quiz, on the examples, you're going to work on the next steps is the simplification of that expression here, okay? This is number 2. Number 3, if instead of a number we have a fraction, let's say we have a fraction a over b, exponent negative n, then this is equal, this is the same thing as of the inverted fraction, b over a, exponent positive n. Let's see an example. So 3 over 7, exponent negative 2, this is equals, invert the fraction, 7 over 3, keep the same exponent but with a positive sign. And then after we're going to see how to simplify and to solve the problem. Any questions about this table here, these definitions here of b exponent 0 and b exponent negative n? Let me know if you have any questions. We will work now on a few examples. Type here in the chat if it is okay, if we can move on, or if you need some more explanation about these slides, or maybe if you want to move on and see the examples and understand by working on the examples. So any feedback, any questions, anything that you don't understand or you need more explanation about these slides? No? Okay, moving on. I'm moving on. Let's work on the examples. And we have a bunch of examples here. The first A, B, and C, they are just a review. A and B, I mean, A and B are reviews because we don't have any negative exponent, we don't have any zero exponent, so it's just a review. If we have letter A, let's say we have negative 2 inside parentheses, exponent 4. How do we find the answer? How do we simplify this? Do you remember? Since we have the parentheses, we have to submit everything, the sign and the number, to the exponent. Negative, if we submit the sign negative to the exponent 4, we're going to multiply negative by negative by negative by negative 4 times, right? This will become a positive. So negative submitted to exponent 4 is going to be a positive. And 2, exponent 4 is positive 16. 2 times 2, 4, times 2, 8, times 2, 16, right? So the result here is a positive 16 or just 16. Next, letter B. Again, this is a review. Now we have kind of the same thing. Check it out. Negative 2 exponent 4. What's the difference now from A? Can you spot any difference? From A we have parentheses, negative 2 exponent 4, right? On B we don't have the parentheses. Can you see this? Can you understand that this is completely different? Why? Because the negative sign is not submitted to the exponent. So you just repeat, you keep the negative sign. The negative sign is not submitted to exponent 4. Only the number 2 is like if you have parentheses only on number 2. Only number 2 is submitted to exponent 4. So we will have 2 exponent 4 is 2 times 2, 4 times 2, 8 times 2, 16. This is going to be negative 16. Completely different from the first one. See, the first is negative is positive 16. The letter A, and letter B now is negative 16. Letter C. Now we have a negative exponent. Negative 2, exponent negative 4. Well, it's kind of the same thing. We just need to apply the properties that we have seen here before. We will invert, right? So the negative sign is not submitted to the exponents. So we keep the negative. Only 2 is submitted to the exponent. That means 1 over 2, and keep the exponent but with a positive sign. 1 exponent 4 over 2 exponent 4, and this is equals to negative 1 over 2 times 2, 4 times 2, 8 times 2, 16. And this is the answer. Questions so far? Nothing? Send me a feedback, send me any questions. Let me know if you are understanding it, if it's okay, if I can move on. Because the next letter D, I think, is the easiest one. Letter D. Can you move on to letter D? I think it's the easiest one because it's an exponent 0. Parentheses, negative 7, x, exponent 0. Okay? When we have anything, any number that's not 0, submitted to exponent 0, this is going to be equals to 1. So we have the parentheses, the whole thing is submitted to 0. That means this negative is kind of negative 1 submitted to 0, 7 submitted to 0, and x exponent 0. Everything is having the exponent 0 when you have the parentheses. That means the whole thing is 1. 1 times 1 times 1 equals 1. Clear? You can skip this step here. You can just write. When you have something like that, you just can write this. Okay, don't need to do this step in the middle here. Very easy. Now, letter E is slightly different. Letter E, because we don't have the parentheses on letter E. Check it out. Negative 7 times x, exponent 0. So negative 7 times x, exponent 0. If we don't have the exponent, the parentheses, that means only the last factor, only the variable x is submitted to exponent 0. So you can keep the sign, negative. You keep number 7, it's not submitted to 0. But x is the only one, is the only thing that's submitted to 0. The x exponent 0 equals to 1. This is equals negative 7. Any questions? And you have this explained right here. If you didn't understand, you can check this out. Okay? This is the solution from the book. It's nicer, it's more organized, it's neat. Maybe if you don't understand my explanation, you can look at this and you can understand a bit better. Let me know if you have any questions. If you don't have, if you're still confused, a little bit confused, don't worry, because we will work on several questions on the quiz. So give me a feedback. Oh, I'm still confused. Oh no, I'm okay. Let's move on. Oh no, I have a specific question. If you have a specific question, type here. I can try to answer. What do you think? So the answer here, to find the missing number, look at the sequence in a different way, for a different perspective. Look it upside down, and you're gonna see the answer is 87. 87. And I'm gonna say Maddie is right, and Keon and Chris, they are right, because when you write down, here is gonna be a 7, right? First here a 7 and an 8. It's 7 upside down and 8. Yeah, Chris DL, Maddie and Keon, you were right. But just write down here 87. 87 as the right answer, just to get the same answer as the Microsoft Forms. Is 87 upside down. Thank you, Chris Dale, thank you, Jacob, thank you, Maddie and Keon and Iriel, and I hope you get to participate more. All these students, I need participation, and just this is a warm-up. This is just kind of a way of getting ready to work on the quiz. And this is our quiz today. Simplify. Let me show one example. The first one, letter A. You have the expression here, the fraction, 2 over 3, exponent negative 1. When you have a negative exponent, it's the same thing as writing down the inverted fraction with a positive exponent, right? And this is equals to 3 over 2. So pretty simple. The question, letter A, the answer is going to be 3 over 2. Question, letter E, another example. 8 exponent negative 2. So when you have a negative exponent, you just invert the base, invert this number, 1 over 8, and keep the exponent, but now positive. This is 1 exponent 2 over 8 exponent 2, and this is equals to 1 over 64. Okay, now try by ourselves. Check all the questions, try to solve it. We can solve together all the questions if you need, you just have to ask. And also I can give you feedback. You can type here your answers, I can tell you if it's right or if we need to fix. Okay, so let's work. I will check out the attendance right now, and after that we can work. Negative 1 squared over 8 squared equals over 64. Sorry, the negative sign, check it out. The negative sign is submitted to the exponent 2. So negative submitted to exponent 2 is going to get positive. Positive. So this is equals to 1 over 64. Yeah. That's it.